Hi, everybody, and welcome to Chapter 3. This chapter is about a topic called combinatorics. Combinatorics is just the technical term that means counting. And since counting is basically the first mathematical activity that all of us did when we were little tiny kids, it seems a little silly to have a whole section where we're studying it now in college. But what you're going to find is that counting is not always easy. Probably this is something you know already. Depends on what you're counting. And so what we're going to be talking about is describing a collection of things and then trying to figure out how many of those things there are. So the collections of things that we're going to be looking at, it turns out that when we're counting things, it's extremely useful to work in terms of lists. We will be working with sets as well. And a list is similar to a set, but it has some different properties. So in particular, a list has an order and repetition is allowed. Those are the two biggies. So what's a list? It's an ordered sequence of objects. The individual things, instead of calling them members, we call them entries. Sometimes we might, I guess, call them members too, but entries is their name in lists. The length of a list is how many entries it has. And we write lists by putting them in parentheses and then separating the things inside by commas. So you guys are very familiar already with ordered pairs. An ordered pair is just a list of length 2. It has 2 entries in it. This right here, this example, this is a list of length 5. It has the entries A, B, C, D, and E. The fourth entry in this list is D, for example. Okay, so you can talk about the first entry, second entry, third entry. In a list, the objects are in order, unlike in a set. Okay. Notes, order matters, so if I put the same things in a different order, it becomes a different list. The list A, B, C, D, E is not equal to the list B, D, E, C, A. They have the same collection of entries, but the entries are not in the same places. And also in a list, you can repeat something, and that counts. So here, the first entry is A, and the second entry is also A, and the third entry is B, and the fourth entry is C. And that's allowed, and that's a list of length 4. There are 4 entries. There's the A in the first spot, the A in the second spot, the B in the third spot, and the C in the fourth spot. Okay, so that's ways in which lists are different from sets. And let me see, maybe just the last thing to mention is it possible to have a list whose length is 0? And the answer is yes, that's the empty list. I suppose if you were to write it, it would just look, this list right here would just look like this, parenthesis, parenthesis, the empty list. It has length 0. And because it has nothing in it, there's only one of them. No matter what set you're talking about your objects coming from, there's only one list of length 0. It's the empty list. Okay, so that's sort of enough for us to get started. Let's go ahead and look at some initial examples. Okay, examples, the first 2 examples I sort of go together. We start with make a list of length 3 in which the first entry comes from this set, ABC, the second entry comes from this set, 3, 4, and the third entry comes from this set, AX. You might pause the video and just make an example of a list like that. I'll give you one example of a list like that. Here we go. Let me see. I'm going to put in the first spot A, in the second spot 4, and in the third spot A. The only requirement is that the first entry has to come from this set, the second entry has to come from this set, and the third entry has to come from this set. So this is one example of a list whose entries comes from these 3 given sets. Okay. Are there any other lists like that? Yes. Pause the video right now and write down all of the lists you can think of that come from those 3 sets, where the first entry is from the first set, the second from the second, and so on. I'm going to go ahead and do it, although I may edit this out later. We have A for A. We have A for X, we have A3A, and we have A3X. We have B for A, and B for X. We have B3A, and B3 x. And then we have, let me see, yes, the ones with C in them. We have C for A, C for X, and we have C3A, and we have C3X. And if I've kept track correctly here, this is all of them. So this is our collection. These are all lists that can be made using entries, first entry from this, second entry from that, third entry from this. Okay. Now, the question is, how many lists are there like this? It's worth going and checking that I've got them all. I'm pretty sure that I do, but please let me know if I don't. Okay, so we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. So how many lists are there? 12. That's the answer. And this leads us to a very important principle, which is as follows. If you think about building lists, this particular list, we knew we were building a list which had 3 entries. I'm just going to put sort of blank squares in for now. 3 entries in it, and in this first entry, it was being taken from a set with 3 elements, so there were 3 options for this one. In the second place, they were coming from this set here, 3, 4, which has 2 options in it. And the third one, this was coming from the set that also had 2 options in it, from another set with 2 options in it. And the idea is you can figure out the total number of lists by following the following rule, which is just if the first entry has 3 options, the second entry has 2 options, and the third entry has 2 options, we can get the total number of combinations by multiplying those together. So the total number is 3 times 2 times 2, which is 12. And this rule is called the multiplication rule. This is the rule that says if you are building lists, it doesn't matter how many entries your list has, whether it has 3 or more, if you can go to each entry and tell me how many options there are for that entry. And if those those options don't affect each other, that is, choosing something here doesn't mean you have to choose something else here or something like that, then you can simply multiply the total number of options for each entry, and the total will be the total number of different lists that you have. Okay. So that's the rule that we call the multiplication rule, or the multiplication principle. That's right back up here, and it's stated in more detail here, but that's the gist of it. If you're making a list of length n, and in the first choice there are A1, we call it, many possible choices. In the second entry in the list there are A2. The A1 and A2 are just supposed to be a number, the number of possible entries in each one. Then the total number of different lists you can make in this way is A1 times A2 times A3 times A4, all the way up. Yeah. Okay. That's it for our first example and introduction to the multiplication principle, and we will come back in our next video for more examples.